Okay, so we're working with a piecewise function here. That means our function is different graphs on different x intervals. So first thing I'm going to do is draw my graph. And I'm going to start by just drawing the line 2x plus 2 the whole way across. And then I can erase and get rid of the parts I don't want, but I'm just going to draw that line. So I'm going to start with my y-intercept at 2. That's where the plus 2 is coming from. And so I'm going to put my dot here at 2. Then I'm going to go up 2, up 1, 2, and over 1, and put a dot right there. And I'm going to go down 2 and over 1 and put a dot right here. And I'm going to draw my line across the whole graph. But then my interval tells me I only want that to exist from -3 until 1. So I'm going to erase the parts which I've got too much graph right now, because my graph should only go from 1, 2, 3 on my x interval until 1, which I already drew, and then I kind of drew over. Now at 1, I want an open circle dot because I have a less than, so I should have an open circle. And then at -3, I should have a closed dot. So I have my closed dot and my open dot. And that's my 2x plus 2 chunk. Now I'm going to do my x minus 3 squared when x is greater than or equal to 1. So the first thing I'm going to do is just graph x minus 3 squared. I know this thing came from the parent function x squared, but it was moved right 3 because of the minus 3 on the inside. So it's just my normal quadratic, but moved right 3. So I'm going to go from my origin, moving right 1, 2, 3, and I'm going to put a dot there because that's my new 0, 0 point. From there, I'm going to draw a parabola. I know I go up 1 over 1. And then if I'm counting correctly, my graph is a little bit off. The up 1 over 1 should actually be more over here if I'm going by my lines for the up 1 over 1. And then it should go the same on the other side. Up 1 over 1. And then from there, if I'm counting correctly, over 2 and up 1, 2, 3, 4 from the origin, then I should land directly on that same dot that I had when I finished my other graph. So now that I see how my function's supposed to be, I'm going to erase this end right here because I don't want it to pass 1. I just want a solid closed dot at 1. I have my open dot around it, but either way will work if you have a closed or open dot there if you filled it in on your paper. So this is what my graph should look like. Then we're just going to run through some attributes really quick. For domain, I know the furthest left this thing goes is 3, but it does hit 3. Sorry, -3, because it's going to the left. -3 over here. Comma, it goes all the way to infinity, because on the right side it's just pointing. For the range, you're going to have to figure out how low exactly this point is. There's a couple ways to do that. I'm just going to go ahead and plug in, if x is -3 to my equation, what's my y? So I'm going to say, okay, what's 2 times -3 plus 2? Because that's plugging in an x-coordinate, it'll get me out a y-coordinate, which would be -6 plus 2, so -4. So that's how far down my graph goes. So for my range, I'm going to have -4, and then it's pointing straight up, so infinity. This thing is increasing. It starts increasing at 3 until 1 is where it starts to change and it drops. And then I'm going to put my union because it also starts increasing again at the x value 3. Sorry, that should have been -3 comma 1 and then 3 comma infinity. And the reason I'm doing this increasing, I'm going to highlight these areas that are increasing. I've got right here, I'm going up, and that's the x-coordinate -3 to the x-coordinate +1. And then I start to go down right here, but then I start to go up again with my increasing at the x-coordinate +3. So that's where that is coming from. So that's my increasing, and then my decreasing was just that red part I highlighted. It's just from 1 to 3. And let's flip this over to the back side. So for left end behavior, I'm going to say the limit of f of x, because that's how I always start my end behavior. Then I'm going to say as x approaches. And if I look at my graph on the left-hand side, I don't approach infinity like on a regular graph. In fact, I only go to the x value, -3. So I just say as x approaches -3. And this is going to equal whatever I get to on the right or on the left side, which was -4. For my right end behavior, again, I have my lim f of x. On the right, however, I do go all the way to the right, so I'm going to say as x approaches infinity. And this equals, since that right end is pointing up, it's infinity. No, this doesn't have symmetry, or I guess you would say neither, because it's not even or odd. For 1 to 1, it's got to pass the horizontal line test. And if I see that parabola shape, I can draw a horizontal line through that. So that would not work. For my x-intercept, I'm going to bring the picture of this graph back. For the x-intercept, I can see there's 2 places that I'm intercepting. I've got one at 0, -1 over here, and then it's, or sorry, -1, 0, and 3, 0. Those are the 2 places that I cross or touch even my x-axis. So my x-intercepts here are going to be -1, 0 and 3, 0. And then I can see my y-intercept happening right there. And so I would just say that my y-intercept is at 0, 2. And that's the whole problem. Just same time. My tests are not super hard. Sometimes, usually I work through lunch too. I don't usually leave my classroom during lunch. Because I just, like sometimes, actually, I don't know, sometimes I do. It's probably half and half. Because I'd rather work through lunch than have to stay later. But some days I just stay later. Like today, we can leave at 2:45, but I didn't leave till like 3:30 or something. So I just wanted to I was just working on stuff, but